The next type of distribution is Gaussian distribution or normal distribution. Gaussian distribution is referred as the normal distribution, and it is defined usually with the continuous random variables. So Gaussian PDF is given by fx of x is equal to 1 divided by sigma root of 2 pi e to the power minus of x minus m the whole square divided by 2 sigma square, where m represents mean and sigma represents variance. Now the Gaussian PDF is given in this way. So it is an increasing and a decreasing kind of a function, so which takes its maximum value at mean and which will be having this kind of a distribution. So its distribution is in this fashion. Now the properties of this PDF are: the first property, the peak value occurs at x is equal to m. So fx of here, even we can write this f as small because it is a PDF graph. So it occurs, the maximum value of the PDF happens to be at mean place, as we can represent it here. When x is equal to m, so this value becomes 1, that would be the highest value because e to the power 0 it would be. Then property 2, the plot of Gaussian PDF has even symmetry around mean value. So about this mean, if we fold across this, if we are folding this graph about m, then we get two equal parts. So it is symmetrical about this axis. Then which can be written as fx of m minus del. So we can consider variance. It could be anything, this place, we can consider a place, and fx of m minus del means if we come some value del on the left and if we move the same value on the right, then we'll be having the same amplitudes. The property third is the area under the PDF curve is half for all the values of x below mean value and half for all the values of x above m. Means, so for all the values m below, x below the m, means on this side the graph is half and on the right side it is half. Of course it is symmetrical, means about m means it has to divide the entire graph by exactly half. So p of x less than or equal to m is equal to p of x greater than or equal to m is equal to half of that value. Then property 4 is as del tends to 0, the Gaussian function approaches to del located at x is equal to m. This is because the area under the PDF curve is always unity. So the area under the curve is always unity. So this, as del tends to 0, the Gaussian function approaches to del, and area under this one is always half because this is half, the rest is half, so which makes it as 1. So it is assumed to be the impulse function. So this all is regarding those properties. So let's solve a problem related to this Gaussian function. Find the CDF, the cumulative distribution function of Gaussian random variable. So fx of x, the PDF is given as the CDF is equal to the integration from minus infinity to x, fx of x is the PDF. So PDF is given by 1 by sigma, the same equation, e raised to minus x. So let's substitute that in and do the integration. And here we are substituting this x minus m divided by del into root 2 as z, and after substituting this becomes e to the power of minus z square, and 1 divided by sigma 2 pi, it can be as it is right now. And then when this x takes minus infinity, then z takes plus infinity value, because minus of minus infinity will make it as plus infinity. And when x is equal to x itself, it is m minus x sigma root of 2, and dx is equal to, so when we differentiate this, minus dx, so del of root 2 is equal to dz, so dx is equal to this value we substituted here. So altogether when we solve, we are getting 1 divided by root pi, integration from minus infinity to the same value e to the power of minus z square dz. So this will be our last solution, and we know that ERFC of u, so in discrete and in digital communication system, so we have this function, that is ERFC of u is equal to 2 divided by pi, so from u to infinity e to the power minus z square dz is nothing but ERFC of u. So this error function is given by this ERFC of, as we are getting the same value here, it is 1 by root pi and all, and to write it in this form we are lacking 2, so let's multiply and divide it by 2 here, so that we can write this one as 2 divided by pi and this value, so this has to be pi. So we'll write this fx of x is equal to half this as it is, it has to be 2, this pi it is ERFC m minus x sigma by root 2. ERFC of u, it has to be u, the limit is starting from m minus x del of root 2, so we write it in this fashion. Then the next, just we need to know the nature of the Gaussian graph. Then the next thing is regarding the uniform distribution. As the name says, uniform distribution, the graph is uniform, or the distribution is uniform, which will be given like uniform PDF, that is fx of x is equal to 0 over the range x is less than m minus pi by a by 2 and x greater than m plus a by 2, and it is equal to 1 by a for m minus a by 2 and m plus a by 2, means over this range it is equal to 1 by a, and for the other ranges it is 0. So such kind of distribution is referred as the normal distribution, or it is referred as, uniform distribution, because the value is same at all the places. And we already know such kind of an example. Show that the mean and variance of a random variable x having the uniform distribution at the interval a b are mx is equal to a plus b by 2 and del x square is a minus b whole square divided by 12. So mean mx is equal to x, fx of x, and when we do the integration we are getting a plus b by 2. This is already been done. And variance is x minus mx square fx of x dx. When we do this integration, we get this one as a minus b whole square divided by 12. And e of x square can be found. E of x square is x square into fx of x dx. So x square fx of x is 1 minus b by a. And this integration of x square, that is x cubed by 3. So after solving, we are getting a square plus b square plus ab divided by 3. So let's solve a problem in relation to this. Consider a uniformly distributed random variable having the PDF of fx of x is equal to 1 over the range is 0 to 1 and 0 otherwise. So calculate its mean square, value and variance. So here, by comparing this one with the given, the lower value is A is 0 and B is 1, and fx of x calculation. Fx of x is 1 by b minus a, which is 1 and it is 0 otherwise. In between 0 to 1 it is going to be 1. So mx is a plus b divided by 2. It is just b is a is 0, b is 1, 1 by 2. And x square is b square plus e square plus ab, which will make it as 1 divided by 3. And then x square is a minus b by 12. So which will make it as 1 by 12. Then another kind of a problem is a random noise voltage x is known to be Gaussian with mean mx is equal to 10 and variance del x square sigma square is equal to 400. Find probability that it exceeds 20 volts, falls between 10 and 20 volts, falls between 0 and 20 volts, exceeds 0 volts, falls below 20 volts. Use Q function. Q of z is given as 1 divided by 2 pi. Integration from z to infinity e raised to minus lambda square by 2 the d lambda. And Q of 1 is 0.158, Q of half is 0.31 and Q of 0 is 0.5 given for our calculation purpose. Now we are given with mx as 10 and del square is equal to 400. So we use the fx equation from the equation we are known with. So it is 1 divided by del root of 2 pi e raised to minus x minus n square. This same equation we use it. And in solving this, the same process x minus, we substitute those all values m and del values and do the same thing. X minus m substitution we do x minus m divided by del into root 2 we are substituting. So let's write it as 20 and this is equal to z. So when we write this much as z, the solution remains like here x minus 10 divided by 20 is z. This becomes e raised to z square divided by 2 divided by this 2 pi and dx is equal to 20 into dz. So e to the power z square by 2 divided by root 2 and pi. So from this we have solved it up till this. It is from 0.5 to, like when z is equal to 20, when x is equal to 20, the z becomes 20 minus 10 by 20, so which is nothing but 10 by 20, which is 0.5. And when x is equal to infinity, this runs to infinity. So when after getting this, let's have a glance on what is given. So 1 divided by root of 2 pi, integration this is equal to is q, then q of 1 and all are given. So we are getting the same value here and it runs from 0.5. So here z and q of z is there. Here it is 0.5. So q of half is nothing but 0.5 whose value is 0.31. So this integration works out to be 0.31 meters. And similarly p of 10, x in between 10 and 20 is equal to, is found by considering p of 10 and between 10 and 20, it is p of x greater than 10 minus p of x less than 20. P of x greater than 10 minus p of x greater than 20. Then to calculate this one, p of x greater than 10 is calculated in a similar way as we do it for p of x greater than 20, and already p of x greater than 20 is there with us, it is 0.31. So even after solving this, we get this as 10 is to integration from 10 to 20, 10 to infinity. Then when we substitute x minus 10 divided by 20 as z, this integration becomes, so it is from 0, because when we take x as 10, this term becomes, z becomes 0, so 0 to infinity. So everything remains same, 1 divided by root of 2 pi e to the power of minus z squared by 2 dz. But integration from 0 to infinity will make this equation as q of 0, and the value of q of 0 is 0.5, 1 divided by 2 pi, the same equation. So 0.19 is the answer. Similarly, p of x in between 0 to 20, in between 0 to 20 is found, like we know already what is the result if it is in between 10 to 20, and we know the property that always whatever is the range from 10 to 20 will be the same from 0 to 10. So from 0 to 20 it has to be 2 times 10 to 20, so we are getting 0.38. And similarly, p of x greater than 0 will be x in between 0 to 20 and x greater than 20. It covers the entire range from 0 to the highest one. So from x in between 0 to 20 is 0.38, and this one is 0.31. X greater than 20 we have taken at first time, it is 0.31, and x greater than 20 is 0.31, and this one in between 0 to 20 we have found it is 0.38. So altogether it is 0.69. Then the functions of single variables. So we can see it in the next video.